Right here is the daily math practice for Unit 3, Lesson 4, Volume and Surface Area, Main Idea 5 and 6. So we are going to talk about surface area, and then main idea number 6 is called lateral area, which is a spin-off of surface area. So let's just talk surface area and get an idea of what it is. So I'm opening this thing up. We've seen this before when we talked about volume. So we're going to talk about surface area now. So here is your box, your prism. And the easiest way to describe surface area is to think of wrapping paper. So think of this as a box that has a present or for Christmas or a birthday, and you need to wrap it in wrapping paper. So you are essentially taking this three-dimensional object and you are wrapping a two-dimensional object around it. Wrapping paper is flat on the ground. And this wrapping paper, if laid out completely, has a length and has a width to it. And we would take this wrapping paper and we would fold it around and over the top of the box. And so the area of this wrapping paper would be the surface area, SA, of this prism. So that is surface area kind of as a concept. Now what we're going to see in this lesson is that surface area is going to be the combination of multiple figures. So I want you to think of it as you're taking the box and you are breaking it down and laying it flat. This is called a net. So now we have this net of the prism. And the net of this rectangular prism now has multiple rectangles. We have a rectangle right here, a rectangle B, rectangle C, rectangle D, rectangle E, and rectangle F. So the surface area of this prism is going to be the combination of all of the areas. A plus B plus C plus F plus E and plus D. Adding all of those areas together will be the surface area. Now this is an easy one because of these boxes. 1, 2, 3, 4. 1, 2, 3, 4, 5. So this is a 5 by 4 rectangle. So A would be 20. 5 times 4 is 20. And you'd continue to do that for all of the rectangles on the prism and get all of the individual areas and add them together. So that's the concept of surface area. Let me go into here. So that is the concept of surface area. And so just kind of revisiting what we talked about, the surface area of a solid figure is the sum of all of its surfaces. Surfaces being the sides. So when I take that picture from the previous one and I laid them all flat, those were the surfaces. Those are the surfaces, the area, those rectangles that we added together are the surface. To find the surface area, you can use a net, a two-dimensional drawing that can be folded to make a solid. That's what we had in the previous, when I took that box and I laid it out flat, the flat rendition of the prism was called a net. Lateral surface area is the exact same thing, just without the tops and the bottom. The total surface area of a solid includes the area of all faces of the object. The lateral surface area includes the areas of all surfaces except the bases. Lateral means side. Lateral means side. So everything except the top and the bottom. Think about a cereal box. You have the back, you have the front, you have the side where the nutritional information is, then you have the top and the bottom. Let's look at some examples of calculating surface area and lateral surface area. So here was your example. We have this prism that is a net. Remember that a net of this specific prism is just a two-dimensional representation of a prism. So like this piece right here, this piece was folded flat and is now right here. This piece here was folded down and is now right here. The top piece is right here. So it's just folded down flat. And what we're going to do to find the surface area is calculate the area of each individual rectangle. So let's do it. There's rectangle A, B, C, and D. We have rectangle E and rectangle F. The surface area is just going to be the area of all of these rectangles added together. So let's find each area. Okay, we have 5 here, so that means this is 5 and this is 7. All we're going to do is length times width. 7 times 5 is 35. Replace A with 35. All I did was length times width. Okay, now we're doing B. That's this one right here. Okay, B has a length of 8 and a width of 7. 7 times 8, that's always a hard one, is, I always struggle with this one, 56. Because then it's 56 plus 8 is 64. We're good. And then we have C right here. C is going to be 7, 7, and 5 right there. So there we go. That's going to be 35. D, that's this one here. That is an 8 by 7. So we have 56 again. E is up here, 8 by 5. That's 40. And F is also 8 by 5. So that's 40. There we go. We have our areas and we are going to add them together. Using a calculator on my phone that's off the screen, 35 plus 56 plus 35 plus 56 plus 40 plus 40. 262 feet squared. There's that. And all I did was do length times width, what, 6 times? 8 times? 6 times? I just did length times width 6 different times and added all the results together. Now let's talk about the lateral area. The lateral surface area is just the sides. So the sides of this thing are right here. Everything except the bases. So I'm doing everything except E and F. So I don't want E and F. I don't want these ones. So the lateral surface area is just going to be A, B, C, and D. A plus B plus C plus D. We already found that. It's right here. 35 plus 35. Oops. Plus 56 plus 35 plus 56. Plug that into my calculator off screen. 35 times 2 plus 56 times 2, 182. Okay, so there's an example of calculating the surface area from a net and calculating the lateral area. Let's look at an example that has triangles in it. We're going to break the shape up into different pieces again. An A shape, B, C, D, and E. Surface area, or SA, is the sum of all of the areas. So we're going to find A plus B plus C plus D and plus E. And lateral area is everything except the bases. So everything except the two triangles. So lateral area is just going to be A plus B plus C. And we're just setting it up. We haven't done any math yet. Let's do A. Let's find A here. So here's A right here. A is 7 centimeters by 4 centimeters. Length times width, 4 times 7 is 28. So I can even set it up over here. A is 28. Plus, let's do B. This is where B has a length right here of 3, but it doesn't seem to have a length right there. But it is this length of B is the same length or width as A. So that means if this section right here is 7, this is also 7 right here. Okay. So we have 7 by 3, which is 21. Plus C. C is 5 by 7. 5 times 7 is 35. Okay, so I'm going to use my eraser here to kind of clean it up, because this is where things can go wrong. We need to find the area of these two triangles, D and E. Now, the thing with the area of a triangle is area of a triangle, so area of a triangle is 1/2 times the base times the height. It's easy, the base and the height of the triangle is right here, 4 and 3. This is called a diagonal, or called a hypotenuse. We don't need that when we calculate the area. So 4 times 3, that's the base times height. 4 times 3 is 12. Divide that by 2 is 6. We have the same triangle up here, plus 6. Now let me go down here. So the area of B is 21. The area of C is 35. So now I have all of the areas. I've calculated all 5 of these areas, and we can now add it together. 28 plus 21 plus 35 plus 6 plus 6. 96. Surface area is equal to 96 centimeters squared. Now the lateral area is everything A, B, and C, everything except the base. 28 plus 21 plus 35. 84. Lateral area is equal to 84 centimeters squared. So there you have it. Lateral area and surface area. Just a lot of small calculations. Writing your work down on paper is going to help you tremendously. If you try and do all of this in your head, I think you will struggle. Reach out to your teacher if you need help.